Hello everyone, welcome back to this amazing channel of Infinity Learn by Sri Chaitanya. I'm your host and host and you all call me AV. And guys, today we are going to discuss the solution of your unit test 6 LTC MPL chemistry. So the one who have already given the particular test, you can directly check the answers and the solution. But the one who are just watching this video for the knowledge purpose, I'll recommend you, please stop the video the moment question comes. Write your answers in the paper and then check the answer as well as the solution. And still have any doubt, please comment it in the chat box. So let's get started guys with this. So first question guys that came, okay, the first question that came in the examination is the characteristics properties of alkanes are. Talking about characteristics property, alkanes undergo substitution reaction, majorly substitution reaction via free radical mechanism. So is it electrophilic addition reaction? No. Is it free radical addition? It is free radical but not addition. It is substitution. It is nucleophilic substitution? No. Free radical substitution reaction, and hence that will be the right answer. So question number one, that is 51. Option number 4 is the right answer. Option number 4 is the right answer. Next, the attacking species in the slowest step of the reaction. Okay, here they are talking about slow step of the reaction. Okay, and if you'll see the substrate is alkene. The substrate is what? Alkene, to be very specific, it is propene. But I'll take alkene. Alkene love to undergo electrophilic addition. Okay, electrophilic addition reaction. That means the first attack that takes place is of electrophile. And the moment that electrophile attack, there is a bond breaking process. And bond breaking process is always an energy required for the bond breaking process and the slowest step. And hence in this reaction, the electrophile, when that electrophile will attack on the alkene, that will be forming the slowest step of the reaction. So if I talk about electrophile, Br will get a negative charge whereas H will get a positive charge. So in this, electrophile is H plus, and hence addition of H plus will form the slowest step of the reaction, or the attack of H plus will form slow step of the reaction. So question number 52, option number 3 is the right answer. Okay. 53. Column 1 reagent, column 2 reaction. Chlorine in the presence of FeCl3 and dark condition. Dark condition, that means no free radical is going to form. FeCl3 acts as a Lewis acid, right? Clear? That means it is going to prepare a chloronium ion, that is holonium ion, and hence it will be acting as an electrophile. So it's an electrophilic substitution reaction, out of which the electrophilic substitution reaction I can found it in option number 2. Okay, alkoxide in the presence of alcohol, this will be acting as a base. Since it is acting as a base, it will undergo elimination, and this elimination, since the base is what? Less bulky, so it will undergo elimination, that is dehalogenation, to be very specific, elimination reaction, and it will give you SATZEF, product. So dehydrohalogenation, no, that is Hoffman's product. This is the reaction. This reaction is right, but the product is wrong. Dehydrohalogenation with SATZEF, yes, I'll go with B, option number 4. Again the same thing, dehalogenation, but the base is bulky base. This is known as what? Bulky base. Okay, bulky base means what? Hoffman's, right? Chlorine in the presence of sunlight is free radical. So A2 not there, A2 not there, A2 2. So 3 and 4 might be the right answer. B goes to 4, B4, C goes to 1, and this. So I'll go with option number 3. That is the right answer. So question number 53, the right answer is option number 3. 54. The reaction of alkene with the following reagent is an example of anti-addition. The reagent is HCl. It undergoes Markovnikov's addition. It is syn addition. Halogenation is an anti-addition, so I'll not go with the further part. 54, anti-addition, that is bromination, that is halogenation reaction. So 54, option number 2 is the right answer. 55, the alkene which is most reactive towards acidic hydration. If you know about acidic hydration, guys, the first step is the formation of carbocation. So more stable the carbocation is, more reactive that alkene will become. So in this alkene, if I'll form a stable carbocation, it will be on this alkene, let us form over here because they both are same. Over here, I'll go with this. Over here, I'll go with this because they both are same. It's a symmetrical alkene. So here if you'll see, the total number of alpha hydrogen that you'll be getting is 5. Here 0. Here total number of alpha hydrogen will be 9 and 3 degree carbocation is there. Over here 2 degree carbocation and 6 alpha hydrogen. So most stable carbocation is option number 3. Okay, or the most stable carbocation will be formed by alkene, that is in option number 3. So 55, option number 3 will be the right answer. 56. Ethanolic zinc dust is a specific reagent for dehalogenation reaction, right? So dehydrohalogenation, no. Dehydration, no. Dehydrogenation, no. Dehalogenation, yes. So 56, option number 4 is the right answer. 57. Which one of the following is not commonly involved in the electrophilic substitution reaction of benzene? Very simple if you'll see. This is halogenation of benzene, nitration of benzene, sulfonation of benzene. They are the electrophile for this reaction. Whereas this is not at all involved. So these three are not the right answer, and hence this will be the right answer because they was not commonly involved. And hence 57, option number 1 will be the right answer. 58. The following product in the reaction is HBr. There is no peroxide, so it will follow MR, that is Markovnikov's rule. Negative part to carbon containing less number of hydrogen. So what will be the product B? Can I say it will be 2-bromopentane? And then if you can see, it's an elimination, that too beta elimination, and it will follow E2. After E2, it should follow Sidzef rule. Okay, it should follow which rule? Sidzef rule. Sidzef rule means for more stable alkene, and hence B, the major product will be this. That is pen-2-ene. In that pen-2-ene also trans will be the most stable one. But since and trans is not given, I'll go with pen-2-ene. So 58, option number 1 is the right answer. 59. Z, P, A, K, and J are the elements belonging to 16th group. So 16th group, oxygen, that is out, standing, Sachin, Tendulkar, player. Okay. So this is the abbreviation to remember. The correct trend of magnitude of electron gain enthalpy in this element is very easy, very easy. Okay, you know that oxygen will be the least one, and rest the order is as simple as the sulphur, selenium, tellurium, polonium, and then oxygen. So what there was the element J. Element J will be what? Oxygen, without any issue. Okay, so 59, option number 4 will be the right answer. Memory based, but yes, easy. Again, memory based question. Statement 1. Formation of H2 and H2S, that is water and sulfides, okay, water and hydrogen sulfide is negative. That is true statement. Why I can say it is a true statement? Because they are what we say, thermal stability. Okay, if you see the thermal stability, it decreases down the group. Okay, the formation of hydride, okay, H2O, H2S, H2Se, H2Te, H2O. This is what the hydrides of oxygen family, that is 16 group family, and the thermal stability decreases downwards. Okay, that is the reason why their enthalpy of formation will be what? Negative. Second, TeO2 is an oxidizing agent. That is also true statement. Okay, why it is an oxidizing agent? Because in TeO2, the oxidation number of tellurium is +4. Whereas in oxygen family, care must be taken that from +4 to +2, if you come top to bottom, the stability or the formation of lower oxidation state increases and the formation of higher oxidation state decreases. So as we come from top to bottom, lower oxidation state dominates. And since over here tellurium is +4 and it is present at the bottom, okay, it is coming like we are coming from top to bottom, it will love to undergo T+2. That means it will love to accept electron. That means what? It is a reduction process, and it is a reduction process. That means what? It's an oxidizing agent. Both are true. So 60, option number 1 will be the right answer. 61. Which one of the following molecule has octahedral geometry? So for octahedral geometry, guys, the minimum thing that is required is 6 side atoms. That means of the type AB6, 1 central atom and 6 side atoms, or 5 side atoms, 1 lone pair, or what we can say, 4 side atom, 2 lone pairs, and so on. So if we'll see in all the cases, if you'll see in all the cases, I can see SF6 with side atoms 6. Sulphur is the central atom, rest is what 6? 6 is what side atoms. So I'll go with option number 2 without any issue. Okay, this is 4 plus 1 lone pair. Okay, 2 plus 2 lone pair. Okay, and here it is sulphur bonds. Okay, so that is the reason why 61 option number 2 will be the right one. Side atoms. 62. Correct statement among the following is, we need to know the correct statement. Rhombic sulfur is stable above 369 Kelvin. Wrong. Memory based. Okay, it is not stable above, it is stable below. Wrong statement. Monoclinic sulfur is insoluble in carbon disulfide. Wrong. This is soluble in carbon disulfide. Both rhombic and monoclinic sulfur are octaatomic. True. Absolutely true. Okay. Both rhombic and monoclinic sulfur are insoluble in water. True. They both are true. So the correct statement are C and D. I'll go with option number 4. Okay. So 62. Option number 4 is the right answer. 63. Contact process is the commercial method of manufacturing sulfuric acid. Okay. The arsenic impurity is been removed by what? Gelatinous Fe2O3. Okay. Gelatinous Fe2O3, and Fe2O3 you can see it over here. Okay. So 63, option number 1. 64. The halogen having least bond dissociation enthalpy. That means least bond dissociation enthalpy means highest bond length or biggest bond length, and that is iodine. So we'll go with 64, option number 3. 65. R, Y, B and P are the elements belonging to 17th group of the modern periodic table. The correct trend of standard reduction potential. Correct trend of standard reduction potential is given by this of this element. R2, Y2, B2, P2. The element R is, we know that the standard reduction potential of fluorine is maximum. Okay, so 65, option number 2 will be the right one. 66. Formula for chloric acid is HClO3. Chloric acid is what? HClO3. So option number 1 will be the right answer. Apart from that, okay, this is hypochlorous acid. Okay. Sorry, not hypochlorous. This is chlorous acid. Wait a sec. This is chlorous acid. Okay. And this is hypochloric acid. And this is what? Chloric acid. Clear? Sure. So again, chloric acid, perchloric acid, hypochlorous acid, and chlorous acid. So let us write the name. Chlorous, hypochlorous, and perchloric. And this is chloric acid. So option number 1. Please try to remember this name. Very important. 67. Regarding hydrochloric acid, incorrect statement. Its pK value is negative. True. It reacts with iron to form ferrous chloride. True. It's a constituent of aqua regia. Yes, HCl and HNO3 forms aqua regia. True. It is a weaker acid than HF. Absolutely wrong. False. So option number 4 will be the right answer. 68. Which one of the following hydride is the weakest reducing agent? Weakest reducing agent means it will not give H easily, and it will not give H plus easily or H easily. That means what? It has a very strong bond. Okay. And since it is a strong bond, it will be a weakest acid as well. So out of all these things, I'll go with HF, because HF has the strongest bond. That is HNS bond, or H halogen bond is stronger in HF, and that's why it will not give hydrogen easily, and hence it is not a strong reducing agent, whereas HI is the strongest reducing agent out of all. So option number 4 will be the right answer. 69. Regarding chlorine, incorrect statement is bleaching property of chlorine is permanent. This is only incorrect. We read it incorrect. The first statement itself is incorrect. So let us mark that answer 69 1. 70. Most electronegative and least electronegative element of 13th group. They are talking about 13th group. Most electronegative is boron. Least electronegative is aluminium. Okay. So where we have boron and aluminium, boron. Okay. Option number 4 will be the right answer. 71. Quartz is an crystalline form of silica. Silicon is hydrophobic. So this is incorrect and this is correct. Second one is correct. So first one, Statement 1 is incorrect. Statement 2 is correct. That means option number 3 will be the right answer. 72. Coke is used as a reducing agent. Correct. Graphite is used as an abrasive. False. Diamond is used. So statement 1 is correct. Statement 2 is incorrect. I'll go with 72. Option number 2. 73. 1 mole of methane, that means CH4, contains 5 gram atoms, that means 5 moles atom, rest, that is right. Out of that 5 moles, 1 mole is carbon and 4 moles of hydrogen atom. So this is true statement. Occupies 22.4 liter at STP, true, because 1 mole of any gas will occupy this much. Contains 2 moles of hydrogen atom, false. Contains 4 moles of hydrogen atom. Contains 1 mole of carbon, true. So ACD, A, B and D. So A, B, D only. So 71, option number 1 will be the right answer. 73. Standard reduction potential value of some electrodes are given below. Thus, from the above data, identify the best reducing agent. Achha, best reducing agent, that means what? It should undergo oxidation, right? And since standard reduction potential is given, we know that the one which shows oxidation will have magnitude. Okay, the magnitude of the negative charge will be maximum. Magnitude of negative charge will be maximum for oxidation. So here it is positive, that means it will undergo reduction. It will undergo reduction. So obviously they should not be the answer. Magnitude, this is positive. Sorry, not this one. Wait a sec. Okay, so this is reduction. Extremely sorry for this. These are two values that are positive. So obviously they will undergo what? Reduction, not oxidation. Now, negative. So let us forget about negative. Which one has highest magnitude? That is the magnesium part. So hence this is the best one to undergo oxidation, and hence it is the best reducing agent. So I'll go with option number 2. It's not like zinc will not show you a reducing agent characteristics. It will show, but the best one is magnesium. So 674, option number 2 will be the right answer. 75. Calculate EMF of the cell of this thing. Standard reduction potential is given. We know that EMF of a cell is equal to what? Cathode minus anode, or right hand side minus left hand side. So this is right hand side, this is left hand side. So right hand side value is minus 0.44, minus of minus 2.71. So if you do this thing, you will get value as 2.27, positive 2.27. So 75, option number 4 will be the right answer. See, 75. The reduction potential of hydrogen electrode is maximum when it is in contact with the solution. So reduction potential we need to calculate, that is EMF of a cell equal to what? Standard EMF of a cell, which will tend to 0 because it is for hydrogen, minus 0.0591 whole divided by number of moles of electron, log of concentration of product by concentration of reactant. What will be the reaction? H plus will take 1 electron. Since it is reduction potential, it will give you half mole of hydrogen gas, right? So can I write this thing as EMF of a cell is equal to minus 0.0591 by 1, because number of moles of electron is 1, log of 1 by what is 1 by what? Concentration of H plus, right? This is a negative value. I want to make it positive. So we know that log of 1 by A is equal to negative log of A. So we'll be taking this thing. So this will be 0.0591 log of concentration of H plus. So I have just converted this thing. This one get divided. So everything is this. So can I say that EMF of a cell is directly proportional to concentration of H plus ion? So what is the concentration maximum? So okay, more the concentration, more will be the reduction potential. So out of all this thing, the maximum concentration is 0.2 molar. So 76, option number 2 will be the right answer. 77. Molar conductivity of concentration is given as 0.01 molar of solution. Specific conductivity of 0.01 molar. So K is also given, that is 10 raised to minus 8. mho centimeter inverse. Molar conductance of a solution is equal to molar conductance is lambda m is equal to x, that is equal to 1000 times into 10 raised to minus 8, because this is what 1000 times into k by m. So 10 raised to minus 8, the concentration is 0.01. I can take it 10 raised to minus 2. Okay, so that will give you 10 raised to 3 into 10 raised to minus 8. This 10 raised to minus 2 goes up, becomes 10 raised to 2. So finally it will be 10 raised to minus 3. So out of all this thing, this will be 10 raised to minus 3. So 77, option number 3 is the right answer. 78. Molar conductance at infinite dilution of ammonium chloride. Molar conductance at infinite dilution of ammonium chloride, this. So of NH4Cl is equal to X, of sodium hydroxide will be equal to Y, okay, and sodium chloride, that is NaCl, is equal to Z. Molar conductance at infinite dilution of ammonium hydroxide is there, what I have asked, ammonium hydroxide. So we can say that molar conductance of ammonium hydroxide will be equal to molar conductance of NH4Cl, because that I wanted, I cannot cancel it out, so Cl, plus I want OH, so OH I'll be getting from this thing, and then I have to subtract this thing by Na and Cl. So it is pretty much simple. Here Cl is in positive, here Cl is in negative, so we can cancel this thing out. Here Na is in positive, Na is negative, so it will get cancelled out. So ultimately it will be X plus Y minus Z. So where is X plus Y minus Z? That is option number 2. So 78, option number 2 will be the right answer. 79. 1 Faraday of electricity can deposit maximum amount of substance at cathode during electrolysis of. We know that 1 Faraday of electricity will deposit an amount equal to their equivalent weight. Equal to their what? Equivalent weight. What is equivalent weight in terms of electrolysis is all about? We'll take molecular weight whole divided by number of moles of electrons. That is transfer or share. Okay, loss or gain basically. So NaCl, we know that Na plus will require only 1 electron. So it is 23 grams. For NaCl it is 23 grams by 1. So that is 23 grams. Sorry. Okay, so it is what? 23 grams. Aqueous copper sulfate. So it is something around 63.5 whole divided by 2. Because copper sulfate is plus 2 ion, sodium is plus 1 ion. So it requires 2 electron, loss or gain. So it will be around how much? Let us take it 64. So it will be 32 gram approximately. Silver nitrate again plus 1. Molecular weight is 108. And the number of electron loss or gain is 1. That is 108 grams. Right, and magnesium, that is plus 2, its molecular weight is 24 by 2, loss or gain electron is how much? 2, so that is equal to how much? 12 grams. So out of all these things, the maximum is of what? Silver nitrate. So this will be the right answer. 79, option number 3 is the right answer. 80. During discharge of lead storage battery. Okay, let us write first of all discharge reaction. So discharge reaction is lead plus lead oxide in the presence of 2 moles of H2SO4 gives you 2 moles of lead sulfate plus 2 moles of H2O. Okay, I hope balance. 2 for the 8, 10, 2 for the 8, 10, yeah, balance. So 2 Faraday of electricity to be generated. Okay, during the discharge of lead storage battery, for 2 Faraday of electricity to be generated, the number of moles of H2SO4 consumed. Okay, so see, 2 Faraday of electricity, if your knowledge serves you right, during discharge or during recharge, the number of loss or gain of electron is 2 electrons. Okay, that means the number of moles of electron is 2 moles of electron. That means 2 Faraday. Okay, for 2 Faraday of electricity, how much moles of H2SO4 is getting consumed? It is 2 moles. So option number 80, option number 2 will be the right one. 81. Stable trihalide of nitrogen is. You should know this thing. Only NF3 is stable halide of nitrogen. Rest all are explosive. Okay. Rest all are what? Explosive. So 81, option number 1 will be the right answer. 82. Nitrogen is not liberated in the thermal decomposition of ammonium nitrate because it will give you N2O, which is a laughing gas. Okay. So I'll go with this option number 2. 82, option number 2. 83. Which one of the following oxide is acidic, colored and paramagnetic gas? Okay. So this is neutral. This is acidic. This is neutral and this is acidic. This you should know. Okay, what is required is acidic. So this should not be the answer. This should not be the answer. Colored. If your knowledge serves you right, it is a blue color solid. Whereas it is a reddish color or reddish brown color solid basically. Okay, it is reddish brown color something. So they both are colored. Talking about paramagnetic. Okay, talking about paramagnetic. This is diamagnetic and hence this is not the right answer. NO2 is paramagnetic because of an unpaired electron. So option number 4 will be the right answer for 83. Option number 4. 84. N2O gas is liberated in the following reaction. Okay, you should know this thing. Again, a memory based question. N2O gas is liberated when dilute nitric acid is treated with zinc. Okay. This is the reaction. Okay, if I want to write the reaction, something around 4 moles of zinc reacts with 10 moles of HNO3. 10 moles of HNO3, which are, yes, obviously it has to be what? Diluted. It will give you 4 moles of zinc nitrate solution plus water plus N2O. Okay, so N2O gas has been formed. So option number 4 is the right answer. 85. Phosphinic acid. Phosphinic acid is also known as phosphorus acid, that is H3PO3. Okay, so 85 H3PO3, option number 2 will be the right answer. 86. The compound B in the reaction is alcoholic KOH, E2 and ZF. But since carbocation rearrangement is not possible, it will give you this reaction. But1 after elimination. This will go and from here hydrogen will go and double bond will be over here. H2O nothing but hydration. It is going undergo what? Hydration. So that is OH. It will give you what? 2 degree carbocation. Rearrangement is not possible because the stability still remains the same and hence OH will attack. So answer will be butane to all. So 86, option number 2 will be the right answer. 87. In which of the following benzene derivative the least reactive compound towards electrophilic substitution reaction? Least reactive towards electrophilic, that means the group that has been attached to benzene is electron withdrawing group, because electron withdrawing group makes a benzene ring less reactive, whereas electron donating group increases the reactivity. Here oxygen is there. How to identify donating or withdrawing? Oxygen contains of lone pair, so it can donate and hence it is an electron donating group or electron releasing group. Again OH, oxygen, electron donating group. Nitrogen, electron donating group. Carbon, and that too carboxylic acid, it is electron withdrawing group and hence that will be the answer. For 87, option number 4 is the right answer. 88. All the following alkenes give the rearrangement product perfect during acid hydration except, so let us form the carbocation. Carbocation 2 degree, it can rearrange, although this way of showing is wrong, but yes, I am just showing this carbocation will be formed over here. Do not think that I have transferred positive charge, I am just showing this can rearrange. Okay, over here 2 degree carbocation will be formed which can be rearranged to 3 degree carbocation. Okay, so not the right answer. Carbocation is formed which can rearrange to benzyl carbocation. Carbocation is formed which cannot be rearranged because it is already 3 degree and highly stable. So this is not the right answer, not the right answer, not the right answer. Option number 4 will be the right answer. Okay. 89. All the following allo compounds are least reactive towards nucleophilic substitution reaction except, okay, if you'll see, this is vinyl halide, this is also a type of vinyl halide, this is phenyl halide. And we know that towards nucleophilic substitution reaction, vinyls and phenyls are highly, what we say, highly unreactive. Okay, they are not at all feasible substrate for nucleophilic substitution reaction. But when we talk about alkyl, allyl, and benzyl, especially allyl and benzyl, they are the best one. And option number one, if you'll see, it is benzyl halide. Option number one comes into the category of what? Benzyl halide. So this all, that is this 2, 3, and 4, they all are what? They all are what? Least reactive, but yes, one will be highly reactive. So that is the odd man out. So option number 1. So 89, option number 1 will be the right answer. Selenium chloride, that Se2Cl2, undergoes disproportionate reaction. The oxidation state of selenium atoms in the products formed is, so if I remember the disproportion reaction, it can be written in this way. You can do the balancing, or let me just balance it. 2 multiply by 2. Yeah, so that is balanced. So undergoes disproportionation, the oxidation state of selenium atoms in the products they are asking about. So over here, so it is 1 is 0. This is not the right answer. And this is -1. So 4 minus 4 plus 4. So plus 4 and 0. Plus 4 and 0. Option number 4 will be the best answer. So 90. Option number 4 is the right answer. 91. In the formation of ozone from oxygen by silent electric discharge, the correct sign of delta H, delta S, and delta G respectively is. So wait a sec. Let us write the reaction. Oxygen giving you ozone, right? So ozone, formation of ozone from oxygen, yes. So here I'll take 3 moles and I'll get 2 moles. So I can clearly see that 3 moles gives you 2 moles of gas. They both are gas. 3 moles of gas giving you 2 moles of gas. That means delta S is negative for sure. Randomness has decreased. Silent electric discharge means what? Energy is supplied. So delta H is what? Positive. What will be delta G equal to? Delta G is equal to delta H minus T delta S. Delta H is positive, negative, temperature, and delta S is negative. So they both will get combined and you will get what? Positive. Okay, negative and negative again will become what? Positive, right? So delta G will be equal to what? A positive value. So this is positive, negative, positive. So positive, negative, positive. Option number 3 suits to be the best answer. So 91, option number 3 will be the best answer. 92. Sulphur forms large number of oxo acids. The oxo acids of sulphur with SOS linkage. Although this is a memory base, you should try to remember this thing. SOS linkage is present in H2S2O7. H2S2O7. If I talk about this one, here you will get peroxy linkage. Here you will get what? Peroxy linkage like this. SOOS. This is peroxy linkage. In H2S2O5 you will get sulfur linkage, and in H2S2O6 again sulfur linkage. So only option with SOS linkage is option number 4. Okay, so 92, option number 4 will be the right answer. Okay, so if you want to see the structure, we can draw the structure as SOS double bond O, double bond O, double bond O, double bond O, OH and OH. Clear? Sure. So 92, option number 4. 93. The following acid cannot be prepared from its salt using sulfuric acid. Okay, if we'll analyze all the options carefully, I'll go with HI. Why HI cannot be prepared by using sulfuric acid? Because sulfuric acid will oxidize HI. So if we'll take HI, if HI is formed in the presence of H2SO4, it will oxidize it to iodine. Okay, HI will directly get what? Oxidized to what? Iodine. Plus obviously SO2 and water will be formed. Balancing you can do it alone. Okay, I am not doing the balancing part, just giving you an idea that if you see this, Only HI is the particular acid that cannot be that cannot be prepared from its salt using sulfuric acid. So 93, option number 4 will be the best answer if HI is formed in the presence of H2SO4. 94. IF5 plus H2O gives X plus HF. Again a memory based question. Try to remember. Periodic acid. Oh sorry, iodic acid, not periodic acid. Iodic acid. Okay. So HiO3 will be the right answer over here. And then 95. Thermally stable fluorides and chlorides of first group element. First group means what? What we say? Alkali metals are respectively thermally stable fluorides. Okay, so thermally stable fluoride, if you remember, it has to be lithium fluoride, and chloride is cesium chloride. This will be the answer. Lithium, and option number 2 will be the best answer. Okay. 96. On long standing, solution of alkali metals in liquid ammonia forms MnH2, that is amides. Okay, so 96, option number 1 will be the best answer. 97. The oxoanion of S block elements which cannot exist at room temperature, and oxoanion, it is beryllium carbonate, BeCO3. Memory base. Beryllium carbonate, yes. Lithium carbonate, no. Beryllium carbonate, yes. Lithium carbonate, no. The oxoanion of S block element which exists as anhydrous salt is Y. Anhydrous salt is barium nitrate. Yeah, it is barium nitrate. BaNO3 twice. So barium nitrate is option number 3. So 97, option number 3 will be the best answer. 98. The oxidation state of sulfur atoms in sodium tetrathionate are. These are some of the molecules that whose structure it is recommended to all the students to remember. So if you don't know this structure, you will definitely end up in marking this thing answer. But this is not the right answer. You have to mark the structure and then you have to see. So the structure is this. All 4 sulfur atoms are bonded together. Okay. How many oxygens are there? 6. So 1, 2, 3, 4, 5, 6, and then sodium, where this will carry a negative charge and this one also carries a negative charge. This is positive charge and this is positive charge. So here what we can do is, see, this is -1, so this will be +1. This is -2, +2, -2, +2. So what is the total charge on sodium? It is +5. What is over here? 0, 0. Out of symmetry, because the first and the last atom is the same, here also I can mark +5. So what will be the answer? +5, 0, 0, +5. So option number 2 will be the best answer for it. 99. In the reaction 3-chlorine plus NaOH, the oxidant and reductants are. This particular reaction, if you remember, even if you don't remember, we can easily say this thing is a disproportionate reaction. Why? Here chlorine is 0, whereas if you go to NaCl, it will become -1, and if you go to NaClO3, this is -2, this is +1, and hence chlorine will become +5. Okay, so 0 to -1 and 0 to +5, it is a disproportionate reaction, and in both the cases chlorine itself is acting as an oxidant and reductant, or oxidizing agent or reducing agent. So option number 1 will be the best answer. Okay. 90. X gram of sodium bicarbonate liberated sufficient carbon dioxide which completely oxidizes 36 gram of coke. So coke plus carbon dioxide give you carbon monoxide, 2 moles if I balance it. So can I say that 1 mole of coke, okay, to oxidize 1 mole of coke to carbon monoxide completely, 1 mole of carbon dioxide is needed. That means 12 gram of coke will require 1 mole of carbon dioxide, right? How many grams is given? 36 grams. So can I say 36? That is 12 into 3. 36 gram will required by 3 moles of CO2. Right? This first is clear. From where this CO2 is coming? From bicarbonate, that is sodium bicarbonate. So NaHCl CO3, NaHCO3, it decomposes as Na2CO3 plus H2O plus CO2. If you want to balance it, you just have to take 2. It will get balanced automatically. So can I say that 2 moles, okay, 2 moles give you what? 2 moles gives you 1 mole of CO2. How many moles is required? 3 moles. That means multiply by 3. So 6 mole. Right? What is the molecular weight of NaHCO3? It is something around 83, if I am not mistaken, something around 83. Okay. Let us try to calculate. This is 23 plus 1 that is 24 plus 12 plus 48. Okay. So what is the answer over here? This is 48, 48, 50, 60, 84. Okay, total is 84. Multiply by 6. 6 8s are 48. So it is more than 480 grams. More than 480 grams, only option is 1. That is 504 grams. Okay, so 100, option number 4 will be the right answer. Okay, so guys, this was all the 50 question that came into your LTC MPL chemistry unit test number 6. So I hope guys you have already got the solution with the answer of each and every question. But still, if you feel like there is some conceptual doubt or that you think that some answer has to be different, please comment it in the chat box. We'll definitely revert with whatever is right. So with this thing guys, thank you so very much for watching this video solution of LTC MPL question number 6. Take care guys. God bless you. Keep smiling.